Hello, this week I'll be talking about the bill of materials for our research vessel for our group NextGen engineers. I am Piero Mortola. I was the project manager for this assignment, and the rest of the team was Alex, Sai, Talal, Victoria, and Brianna. I will be going over the executive summary for this assignment, the methodology of how we went about researching the components for the bill of materials. Um, then I'll get a little bit into the details for each system, and then finally an overview over the overall bill of materials for the whole vessel. As a reminder, our team chose a 34-foot single-engine vessel configuration. Our main goal driving this choice was to minimize the cost of building the ship while maintaining high reliability while the vessel is out doing research. We also needed to consider where the vessel will be doing its research. Um, of course, it'll be doing it in the Gulf Coast, so we needed to keep that in mind when choosing the components for our vessel. To help split up the research, we broke down the vessel into its core subsystems listed here. The propulsion, electrical, sanitation, freshwater, the whole construction itself, the anchoring system, and the navigation system. Further, uh, in each system, we identify the core components um, for that system, which gives us an estimate for the total cost for each individual system, which we can add up at the end to get an estimate for the total cost of our vessel. For our whole construction, we used a rough estimate that 50% of the total vessel weight will come from the hull and deck, and given that for our specific um, vessel configuration, the average weight tends to be around 8,000 pounds. Uh, this gives us a rough estimate of how much raw aluminum we need, around 4,000 pounds. We identified two main aluminum alloys that will be effective for the marine environment, aluminum 5086 and aluminum 6061. Aluminum 5086 is a little bit more malleable, and so will be used for the plating and the deck, while aluminum 6061 is a little bit more stiff and strong. So it will be used for the structural framing of the vessel. Aside from the aluminum, um, the hull will need some kind of anti-fouling paint, which protects the wetted area of the vessel. Um, we also need sealant, sacrificial anodes to protect from galvanic corrosion, and some kind of anti-slip epoxy for the deck, as well as a properly sized rudder for our 34-foot vessel. The key component for the propulsion system is of course the engine, which needs to be large enough to propel our vessel, which should be around 8 to 9,000 pounds. We identified that around an engine of around 350 horsepower uh, should work well for our configuration. Um, we also saw that keeping the uh, different components for the system, uh, keeping the same supplier ensures that the components are all compatible with each other. Also, as a quick aside for the table here and the rest of the tables, these are not the full tables. These are a cropped version of the tables, as they were a little bit too big for the slides. For our vessel navigation equipment, we decided to focus on precision, ease of use, and safety. Our system includes a variety of equipment such as high accuracy compass, joystick steering, a chart plotter, and an autopilot system. This allows for precise tracking of the vessel location, which is a requirement when performing research on the coast, which might need some kind of surveying of um, the waters. For the electrical system, the biggest factor in choosing our components was reliability, as all the other subsystems um, are reliant on the electrical system, as well as the research equipment. Having a reliable, robust electrical system means that the vessel can actually function. Um, and the way that we identified to do this was to choose marine grade equipment that's built to stand the environment, the marine environment. Generally, when working with people, you need to provide clean, safe drinking water. So we need a system that can do that. Again, components are marine grade to maintain reliability and long-term performance. The system is designed to minimize pump cycling, provide steady water flow, conserve space, and ensure easy maintenance while delivering clean, safe water for drinking, washing, and showering. For the sanitation system, like the other systems, we select the durable, corrosion-resistant components for the marine environment. Um, the particular waste management system includes a macerator pump for easy discharge with a vented loop to prevent siphoning. These systems are designed to minimize maintenance, especially while out on the water, while maintaining high standards of hygiene and safety on the boat. The anchoring system was sized to the boat, as well as the conditions on the waters. Typically, we will have sandy soil on the Gulf Coast, so we want a fluke style anchor. And typically on the Gulf Coast, we also have very shallow uh, waters. Um, so we size the chain according to the um, typical depth or anchoring depth uh, for the Gulf Coast, which we found to be around 25 feet. Finally, adding up the individual systems gives us an overview of the bill of materials, the overall bill of materials. While not an exhaustive list of the necessary components, this gives us a good estimate of the overall cost of the vessel, um, which, as we mentioned earlier, was a design factor in choosing our small configuration, um, while maintaining a similar performance to those that might be a little bit more costly.